Hello, everyone. In our last lesson, we introduced the structure and working principles of the handling workstation. We designed the electrical and pneumatic diagrams and distributed and tested the signals for the workstation. Today, we will proceed with the installation and debugging of the equipment based on the signal distribution table, electrical schematic, and pneumatic diagram discussed in the previous lesson. This lesson mainly covers the following content. First, we will distribute signals on the robot side according to the I/O distribution table from the last lesson. The signal distribution table is shown as follows. From the table, we learned that the signals for the digital pressure gauge and vacuum cup are connected to the EE interface on the robot body. There is no need for us to configure these signals, we just need to wire them according to the electrical schematic later. Here, we need to configure the conveyor belt signal to the 25th pin signal channel on the CRMA15 card and define it as DI120, configure the conveyor belt tooling fixture solenoid valve to the 40th pin signal channel on the board and define it as DO120. The specific configuration parameters are shown in the figure below. When configuring signals, be careful not to conflict with signals that have already been configured. If a conflict arises, you will need to adjust the previously configured signal channels or the design principle diagram of the handling workstation. Next, we need to install the vacuum cup at the flange of the industrial robot's 6th axis. From our previous studies, we learned that the robot picks up materials through a vacuum cup. Next, let's install the vacuum cup on the robot by watching the installation video. Proceed with the electrical wiring and pneumatic connections according to the electrical schematic and pneumatic diagram. The EE interface is a 24-pin connector. As we have already introduced in our previous lessons, in this case, we only use the RI1 and RO1 signals from the EE interface, along with the positive and negative wires of the 24-volt power supply, for wiring signals in total. This is because we do not need to draw out all 24-pin signals, we only need to draw out the signals for the pins we are using. As shown in the wiring diagram of the terminal block, this set of wires corresponds to the EE interface connection. We only need to take the few signal wires that we require. You can see, this wire corresponds to the RI1 pin, and we connect it to this port of the terminal block group. Then, this wire is the connection from the RO1 terminal pin, which we connect to this port of the terminal block. These two wires are the negative and positive signals of 24 volts drawn from the EE interface, respectively. We introduce them into these ports of the terminal block. After completing the EE interface wiring and introducing it to the terminal block, we will wire the other side of the terminal block. Now, look at the RI1 interface wire. We connect the pressure detection signal. Therefore, this black wire is the output wire for the pressure detection signal. We connect it to the RI1 interface through this wire, thus forming an effective connection. This wire is the control line for the pneumatic control valve. We connect the control line of the pneumatic control valve to the RO1 interface through the RO1 interface, thereby completing the connection. For the remaining control valve's negative terminal wiring, we introduce it into this interface, which is the negative terminal connection wire. Then, we connect the positive signal of the pressure detection to this interface, connecting it with the positive signal of 24 volts. This completes the electrical wiring on the EE interface side. After completing the electrical wiring of the EE interface, we move on to another part of the wiring, which involves connecting to the robot's DI and DO interfaces according to the signals in the electrical schematic. These are connected to the robot's CRMA15 interface. Next, let's see how to wire this interface. From the previous I/O distribution and interface allocation, we know that both the conveyor belt material detection signal and the solenoid valve controlled signal for the conveyor belt tooling fixture are assigned to the CRMA15 interface. So, let's wire these two signals. This black wire is the output signal wire from the conveyor belt material detection sensor. We connect it to the 25th pin port of this terminal, corresponding to our configured signal DI120. As for the control signal of the conveyor belt tooling fixture, this red wire, we connect it to the 40th pin port of this terminal, corresponding to DI120. This completes the wiring for these two signals. The power lines for these two devices can be connected to a nearby power interface on site. This completes the electrical wiring for the robot. Next, let's watch a video on connecting the pneumatic lines. Now, let's connect the robot system's pneumatic lines according to the pneumatic diagram we designed in the last lesson. Here, you can see an air intake port for our pneumatic system. We installed a valve at this air intake port and connected the main air hose entering the robot to this main valve of the pneumatic system. The other end of the hose connected to the main air intake port will be connected to the Air 1 intake port on the robot body. This is the main air intake port of the robot, which we have already introduced in previous lessons. It is located on the base of the robot. We connect this hose into the connector, and there will be corresponding internal pneumatic connections within the robot. After the air enters the main intake port, there will be an Air 2 outlet on the third axis of the robot, along with overall debugging. First, we run program 0005. The specific steps are as follows. Select the Select menu, then choose Create, select F1, input 0005, and then click OK. After creating the program, we select F3 to edit. This allows us to access RSR 0005. Once accessed, here we see a driving control valve resistance. We will connect the line from the pneumatic connections output port to the intake port of this pneumatic valve resistance. Here, we have two pneumatic valves for pneumatic output. The suction cup we use is controlled through one of these valves. Therefore, we need to connect the pneumatic line of the vacuum suction cup we are using to the output port of this valve. Let's proceed with the connections. This valve has two pneumatic outputs, but we only need one of them. Therefore, we seal off the other output using tape. Next, we connect the pneumatic line controlling the vacuum suction cup to the output port of this valve. According to the schematic diagram, the next component we connect is the vacuum generator, which we install in this position. We connect the valve's output hose to the intake port of the vacuum generator, right here. Now, let's make the connection. The hose from the vacuum generator's output port will be connected to the corresponding suction cup on the gripper hand. From the vacuum generator's output port, we use a Y-splitter to divide the pneumatic line into two. These are then connected to the connectors for these two sets of vacuum suction cups. We've completed the first set of connections, and now the second set of connections. With that, we have completed the entire robot's pneumatic connections. After completing the electrical wiring according to the schematic diagram and the pneumatic connections, we will proceed with signal testing. Let's watch a video on how to conduct the test. After completing the pneumatic and electrical connections, we will next test our signals. We will do this by monitoring the corresponding input and output signals on the teaching pendant to verify the correctness of our previous wiring. Next, we will test these signal interfaces through the teaching pendant. First, we test the EE interface. The method is as follows: select menu on the teaching pendant, then select the I/O option. Choose Robot in the main menu, and enter the Robot menu. Here we see the monitoring screen for the RI interface. By clicking F3, we switch to the monitoring screen for the RO interface. Here, we have added comments. RO1 is a control signal for the vacuum suction cup. We move the cursor to RO1. Select F4, and force the RO1 interface to output ON to see if there is a signal for the vacuum suction cup. We set it to ON. And we hear the vacuum suction cup making a suction sound. Once the vacuum suction cup starts to make a suction sound, next, we place a piece of material on the vacuum suction cup to see if the suction can hold it firmly. Through testing, we see that the material is very firmly attached to our suction cup. Once the vacuum suction cup has sufficient suction, the RI1 signal will receive pressure feedback. Let's check if there is a signal input on RI1 on the teaching pendant. We press F3 to switch to the RI monitoring screen, and we can clearly see that the RI1 interface has already shown an on state, which proves that the current pressure value has reached the desired state, and the signal, connection, and wiring checks are all correct. After completing the E interface signal test, next, we will proceed with testing the DI and DO interfaces, specifically the signals on the CRMA15 card. We select Menu, then I/O, then Digital. First, we enter the DI interface. We move the cursor to the EI120 interface. And next, we test the signal from the sensor on the conveyor belt by placing our hand in the sensor's detection area. We see that when we place our hand in the sensor's detection area, the DI120 signal changes from off to on. When we remove our hand, the DI120 signal changes from on to off, which proves that our signal wiring and configuration are completely correct. Next, we perform the DO120 interface test. We switch interfaces using F3. And now we move the cursor to DO120. When we select on the teaching pendant, the workpiece holder on the conveyor belt will be extended. Let's try it. We see that when we select on, the clamp extends. And when we select off, it retracts. This confirms that our DO120 signal wiring and configuration are completely correct. Through this video lesson, we have completed the corresponding wiring and signal tests, and these methods allow us to verify the accuracy of our wiring and signals. In this lesson, we have learned how to configure signals based on the assigned I/O table, and how to wire according to the designed electrical schematic diagrams and pneumatic diagrams, as well as test the signals. These are essential skills in robot system debugging and lay a solid foundation for mastering the use of robots.